Here we go. The set of rules for simplifying an expression is called the, yes? Order of operations. Now, throughout the day, I've had students saying PEMDAS, and that kind of helps you remember the order of operations, but that's not really the order of operations. Does that make sense? So you're not going to see PEMDAS as a multiple choice answer on a test or a quiz. Do you guys understand? So use the correct terminology. It's order of operations. Here we go. Okay? All right. Now you're going to find the value of each expression. Now these are expressions, but specifically they're called numerical expressions. So I'm trying to get you guys to know the difference between a numerical expression and what we're working on today, which is an algebraic expression. Okay? So who can explain this first problem to us? Go ahead, Zach.
So the first step you have to do is 4 times 2, since multiplying comes before addition.
Very good. So Zach's correct. The first thing you're going to do is you're going to multiply, because in order of operations, multiply comes before addition. So 4 times 2, and what is 4 times 2? 8. Right, so if you see here, 3 carries over, and then 4 times 2 becomes 8. Now what's next? I'm going to add, and what do I get when I add these two numbers? 11. Very good. Okay, who's got the next problem? And this is division, by the way. Some students were having a hard time seeing that. India, go ahead.
So the first thing you have to do is divide 6.
Okay, right. The first thing we're going to do is we're going to divide. Now this caught a few people earlier today. So when you divided, what was your expression that resulted from that?
2.
It's 2, but what's the sign of 2 going to be? India. So I'm trying to get you guys to think about what I taught you in the past. This is a -6 divided by a +3. They're different signs, right? And when you divide different signs, the quotient sign is going to be negative. Different signs negative. So I have 12 minus 2 now. So what was your final answer? 10. So 12 minus. So you did put a negative in there, it sounds like. Okay? Are we good? Who's got this one over here? McKinley. McKinley, can you not call out over people? Thank you. Go ahead.
So first, you know, when you're doing this in parentheses,
Right, let's do that.
I got -2.
Nice. And that's perfect, because I have a +5 and a -7. They're different signs. You take the difference and you keep the sign of the larger magnitude. So it's going to be 2, and 7 is the larger magnitude, so it's going to be a -2, because 7 was a negative. Okay? Right, so I have a +6 times a -2. They're different signs, so my product sign is going to be negative. So I get -12 plus 2 now. And then what's the final answer going to be? Very good, -10. Nice. Okay. And who's got this last one? Kimberly, go ahead.
So first you have to do what's in the parentheses. So 4 plus 3 is 7.
Okay, very good. So we took care of the parentheses first.
And then after that you have to do +7 times +2.
Very good.
+14.
Very good. So we have +14 and we have a -11 left over.
That would be +3.
Very good. +3. Any questions about the warm-up? We're good? All right. If you notice, from every step, it's well documented what happens from one step to the next, right? Okay. I need you guys to be very careful about the way you're showing your work, because when it comes to solving equations, if you're not careful, that's where people mess up, okay? So make sure you're doing a good job of showing your work from one step to the next. So here's what we're working on today. This basically gives you a summary of what's happening for the entire unit. What you'll learn next, in Unit 5, you're going to learn to solve equations and inequalities by adding, subtracting, multiplying, or dividing. You'll learn to write inequalities and graph their solutions on number lines. What you'll learn today, you're going to learn to write and evaluate algebraic expressions. Remember in the warm-up, we were talking about what kind of expressions? Those were numerical expressions, all numbers. Got it? Today we're talking about algebraic expressions, and algebraic expressions differ from numerical expressions, and we're going to see how. New vocabulary, a variable, algebraic expressions. Okay, you can use you can use algebraic expressions to help you make predictions based on patterns. If you know how far you can swim in 1 minute, you can estimate how far you can swim in 5 minutes. A variable is a symbol that represents one or more numbers. Variables are usually letters. An algebraic expression is a mathematical phrase with at least one variable. So a numerical expression has no variables in it, only numbers. As soon as you see a numerical expression and there's a letter in there somewhere, it's no longer a numerical expression. It is a algebraic expression. You guys got it? Any questions about that? Okay, moving right along. All right, so here we have a diagram. We see the word phrase, a diagram that represents a word phrase, and the algebraic expression that represents the word phrase and the diagram. So if you look at the first one, we have a temperature of T degrees, and the key word here is increased. Increased by. And if you notice, that's a key word for addition. Now there's more keywords than increased by. There's other keywords. What are some other keywords for addition? Altogether. Does somebody have another one? For addition, a keyword? Add to. Mm-hmm. The sum, nice. Anybody got another one? Plus, okay. Okay, there's a few. Just wanted to bring up a couple. If you look at the diagram, here we have T, and then plus 5, and that gives you the total sum, which is T plus 5. Okay. Any questions about the first one? All right. 5 cats fewer than C cats. Okay, well, here if you have C cats and you take away 5, so if I was to take away 5, I'd be left with the difference, that part. You guys understand what the diagram's trying to depict? Okay, it's not important that you understand it. If you don't understand it, I wouldn't stress too much of it. You're not going to see this on a Connexus assessment. You might see it on Park, but you're not going to see it on a test or quiz in this class. Okay? All right, and if you look fewer, it goes with subtract, right? So fewer than, we have subtraction. Okay? What are some other words besides fewer than that are keywords for subtraction? Go ahead.
Less than.
Less than, very good. Got another one? How about you, Justin? The difference, nice. McKinley? Take away, good. Okay, there's a few. The next one, the product of 5 and n nickels. So if we're talking about product, what are we talking about when we talk about product? Multiplication. Now here there isn't a sign for multiplication. Do you see that? This is what throws off a lot of students in math. There's more than one way to write multiplication. You could represent it with a multiplication sign. You could represent it with the dot, like we did in the warm-up. You can also represent it with parentheses. And then this way, if you have a number next to a variable like this, it's also multiplication. So this is 5 times n. 5n is 5 times n. Yes?
It's kind of like when we did the numeric expressions when we used PEMDAS for the order of operation.
Right.
Like some numbers would be right outside of the parentheses.
Right, exactly. Mm-hmm. There's a number of ways, and I'm trying to emphasize that with you guys. That means multiplication. This right here means multiplication, even though you don't see a multiplication sign. Any questions? Okay. Now, we have a dinner bill of $D divided among 5 friends. So we have D here, and then if we split it up 5 ways, here we got D over 5, D over 5, D over 5. D divided by 5. Or what's another word for divided by? Anybody? The quotient, nice. That's one that's used not as frequently as others. You got another one? Divided by, dividend. What's the dividend? Yep. Any others? Okay, let's go and move on. Writing word phrases. Write an algebraic expression for each word phrase. Swimming m meters per minute for 3 minutes. What would be the word phrase? What would be the expression for that word phrase? What's happening here? Somebody I haven't heard from? Zainab? What do you think that's going to be? Take a guess. What do you think the operation is going to be? Right, multiplication. So how would I write this as a multiplication? 3m. Very good. 3m. There's more than one way to write this. I could have written it this way. I could have also written it this way. Okay? Or I could have written it this way. Be ready for the different ways they might show it to you. Okay? McKinley, do you have a question? Or you want to share your answer?
If you write
3 of m. I guess it just depends on the context. There's many, many ways to have a word phrase. I'm going to try to keep it simple today and not get into like the different ways or variety of ways you can say multiplication. Who's got this next one? 12 heartbeats more than X heartbeats. Go ahead, Goldus. Okay, so give me the expression that would go with that.
12 plus X.
Okay, so what you just said was X more than 12.
I mean 12 plus X.
12 plus X. You just, again, did X more than 12.
X plus 12.
Nice. Now for operations that are commutative, that means you can change the order. It's okay, but it's not always going to be okay. So I want you guys to conceptually know what's going on. And this is how they will try to throw you off on a standardized test. They'll try to word it like that to trip you up, okay? Who's got this last one down here? Write an algebraic expression for a price P decreased by 16. Who has that one? Yes, Leah.
16 minus
Jose. Right, decreased by 16. So it's P minus 16, decreased by 16. You're subtracting by 16. Got it? Okay. Sometimes what's useful is I would actually put something in to the phrase, like 7 decreased by 16. And then hopefully that'll help you understand, like which is the order, okay? And that would give you a negative number, but you get the idea. Okay. Any questions? Can I move on? All right. The Environmental Club is making posters. The materials for each poster cost $4. Write an algebraic expression for the cost of the posters. So what's happening here? What's happening? Lopez, what's going on here? What operation do you think is happening? Multiplication. I would agree with you. I'm going to say multiplication. Each poster costs $4. We're going to multiply that by the number of posters, right? Okay, so what would your algebraic expression look like? Right. 4 times P or 4P. We good? Okay, moving right along. 9 students will hang T posters each. Write an algebraic expression for the total number of posters the students will hang. So take a moment, take a guess, or if you know it, write it down. Who's got the answer to share with us? Ben. What's the answer? Nice. 9 times t, the number of students 9 times the number of posters that they hang up gives us 9 times t, or as you said, 9t. Any questions? Nope, we're good? All right. This is a super easy lesson. I feel like it's a nice introduction to the unit. 3 different word phrases for x plus 2. Now, I'm just going to give you a hint. Anytime you're asked to write a word phrase, if they're not saying exactly what the variable is going to be used for, just say a number. Does that make sense? So instead of using the variable, instead of saying x, say a number. Okay? So who's got the first one? We talked about a couple key phrases besides for addition, right? What are some key phrases we can use? Justin. What's that? More than, right? So we could say more than, and if we said more than, replace 2, and then instead of saying x, say a number, and then put the word more than in there somewhere. So give me a phrase from those 3. Instead of using the variable x, say a number. Just say a number. Not replace it with a number. Just say the phrase a number. Because we don't know what x is, right? So, do you understand what I'm saying? So I'll give you an example. A number 2 more than a number. You understand? There we go. But I understand where the miscommunication was. You put a 3 in for x. Okay, that'll work. Do you understand what I'm saying, though? Okay. Can somebody give me another example? Who's got another example for me of addition? Rayhan.
2 plus 3.
What?
No, 2 plus x. No, 2 plus a number.
2 plus a number. I think that works. Or a number plus 2. Okay. Who's got another one? This word gets used a lot in word problems. McKinley?
The sum.
Yes, the sum. I like that. The sum of a number and 2. Who's got another one? This one, I really need you guys to know this one because I see this all the time in word problems. Jose?
The addition of a number and 2.
That's correct, but I'm looking for another one. Kimberly?
A number increased by
Nice. A number increased by 2. Okay. Let's go over this next problem. Write 3 different word phrases for a c minus 50. Now, there's more than what I'm showing up here. Okay, I'm just trying to give you some common ones. Mm-hmm.
the difference of a number and 50.
Nice. The difference of a number and 50. Amari.
50 less than.
Nice. 50 less than a number. All right, Ben.
A number decreased by 50.
Nice. And I need one more, and we can move on. Somebody I haven't heard from in a while. Bokar. Come on, Bokar.
A number. Oh, 50 is. Wait, it has to be 3 words, right?
It could be more than that.
50. How many more does a 50 go into a number?
No.
Oh,
Goldust, go ahead.
a number minus 50.
Number minus 50. Or 50 subtracted from a number. There's a couple different ways. Are we good? Any questions? Use these keywords. Now, look, if you're asked to make a number a word phrase, instead of using the variable, replace it with the word phrase part. Just call it a number. We don't know what number it is, just say a number. Do you guys understand? And I'm trying to get you guys ready because on a quiz or a test, they might give you a word phrase. They might say a number divided by 13. and you're supposed to show the algebraic expression from that. Do you guys understand? So I'm just trying to get you guys ready for things to come. All right. Now, what you're doing here, you can substitute for a variable to evaluate an algebraic expression. If you take a look at the example, we're going to evaluate each expression, and we're going to use these values. Use the value p equals 2, n equals 3, and s equals 5 for these algebraic expressions. So here's the first step. You're going to rewrite these algebraic expressions by substituting these variables with these numbers that they give you so that you have a numerical expression. Then it's just like the warm-up. Do you guys understand? Show all your work, where you started, what it ends up being after you substitute, and then your work to simplify the expression. Athila, what's the first thing I got to do here?
For 2p plus 7. First you need to find, so p equals 2.
Mm-hmm.
So that's 2 times 2.
2 times 2, because 2 times p, but p is going to be 2 now, so 2 times p. And then we got the plus 7, so now what do we do? What's the next thing?
Add 4 plus 7.
And how'd you get to 4?
I did 2 times 2.
Right, so the next step is to do order of operations, which is going to be multiply first. So 2 times 2 becomes 4, and then 4 plus 7 becomes 11. And you guys see how I worked this out just like we did in the warm-up? Okay. Who's got this one over here? Walk me through it. Somebody. India. I saw your hand was up. Was it not up?
It wasn't up.
Oh, it looked like it was up. I'm sorry. Okay, go ahead.
P equals 2 and n and s is 3 times 5.
Okay, very good. So here's what we got. You replaced your variables with the numerical values. Now we went from a algebraic expression to a numerical expression. I'm trying to use a lot of repetition here so you guys don't forget this. Okay, now what?
You add them all together.
Hold on, add? Are we doing addition first?
I mean, you do multiplication first.
Okay, we gotta do what's in the parentheses first, and it happens to be multiplication, right? Because please is parentheses, that's the first thing. Excuse, there's no exponents in here, right? There's a my dear in here, right? So let's go ahead and take care of what's in the parentheses.
3 times 5 equals 15.
Okay.
15 plus 2 equals 17.
Okay, are we good? Any questions about that? Do you have a question about this?
How did she get 3 and 5?
Because she replaced these variables. Okay, do you see what she replaced and where she got the numbers from? Okay. Now, who can walk me through this example? Zainab. Mm-hmm. Right. Okay, so here's what we got when we replace those things. Okay? Yes, we're going to do parentheses first, and what do we get when we simplify what's in the parentheses?
8.
Very good. And then what's the last step? 8 times 7 is 56. Any questions? Okay, last slide. So a numerical expression is a mathematical phrase that uses numbers. What is the difference between an algebraic expression and a numerical expression? Who can volunteer to give me an explanation there? Teray, go ahead.
An algebraic expression uses variables and a numerical expression only uses numbers.
Right, so an algebraic expression has at least one variable. A numerical expression has no variables. Okay, the book goes one step further and they explain it this way. So here's the book's answer. An algebraic expression differs from a numerical expression because it contains at least one variable and the value changes. So if we go back to this problem over here, notice that they assign these variables values, right? But they could have given them other values. Do you understand? So if we go back over here, that's really what they're saying. The value can change depending on what you assign the variable. Okay, are we good? Now, Tell which operation you would, that should be a U. Which operation would you use for each word phrase? So 6 goals fewer than G goals. What's the operation here? Subtraction, very good. Over here, P people increased by 2. What's the operation? Addition, very good. Okay, write a word phrase for each algebraic expression. Who can give me the first word phrase over here? Justin in the back, go ahead. A number less than 3? Or they're actually using the variable again, but I like that you replaced a number with the variable. So 3 less than W. Okay, and notice the order too, because they're saying the number is 3 less. Okay, who's got this next one over here? Yes, Jonathan. 5 times a number. Is there another word we can use besides times? Begins with a P. The product. The product of 5 and W, or a number. Okay? Now, I'm trying to get you guys to think of certain keywords that I know are going to come up. All right, product, quotient, difference, sum. Okay, what about this one right here? Who's got this one? Go ahead.
The sum of 12 and a number.
Or the sum of 12 and a number, or 12 more than a number, or 12 more than W. Okay, and this last one, this one threw a lot of people all day long. But it's once they hear it, they're like, oh, okay, it's not that tough. What is it? Go ahead. Very good. The quotient of W and 4, or the quotient of a number and 4. Okay, both work. All right, now this is pretty easy. This is just what we did in the last slide. All you're doing is taking the algebraic expression, make it into a numerical expression based upon what they've assigned P. Okay, and this is really fast, so let's go and walk through this. What's this going to be? 10, because we replaced P with 2, and 2 plus 8 equals 10. What's this going to be? 6, very good, because we replaced P with 2, and 3 times 2 is 6. Okay, here we got 14 because 16 take away P, which is going to be 2. 16 minus 2 is going to be 14. And then over here, you're telling me 6 because 12 over P is the same as 12 over 2, and 12 over 2 is the same as 6. Okay, any questions? All right.